You're going to get a lesson on explicit and implicit equations. And in this section, we're going to talk about implicit differentiation. So let's talk about these types of equations. Normally, when we talk about equations, or up to now, you've looked at equations in the explicit form, where one variable is solved for the other one. So y is an explicit function of x, where we just have y on one side and everything else on the other side. So we can have a nice little function here. We can plug in a number for x and get a y out. Okay, so this would be like f of x is equal to 2x plus 3, and we know that this is an equation of a line in its most simplest form, slope-intercept form, right? Okay, then we can have y in a different form, f of x, and we notice that y is on one side and x is on the other. These are explicit equations. Even if we have something that doesn't involve x and y, where we have one variable on the one side and the other variable on the other side, this is also an explicit equation. Implicit equations are equations like a line in standard form, where x and y are on the same side of the equation. Now we could make this equation look like the explicit equation by solving for y, but sometimes we don't want to solve for y, and we just want to take the derivative as the way it is. Or something like this, where x times y is equal to 9. And even if we use a different variable like m and n, we can say m times n is equal to n plus n, and so on. So there's a lot of ways that we can write equations. So now we're going to learn a different way of differentiating these equations. It's not as bad as it sounds. Okay, find the derivative with respect to x means to do this, d something dx. So we're going to find the derivative of a variable with respect to another variable, and this has to be pretty clearly stated so you know which one to use. But as a general rule, we're usually finding the derivative of y with respect to x. Okay, so if we're taking the derivative of this, we can say that dy dx is equal to the derivative of y, and we just go ahead and take the derivative. Okay, nice and simple. And if we think about it, if we use the chain rule and we take the derivative of this, this is my u here, so take the derivative of u, and then we have to take the derivative of u, which is just dx over dx. We're going to have the derivative of x over with respect to x, which we don't really write because we don't need that, because that reduces as a fraction to 1. Okay, now let's try this as a more of a second example, because you may be confused right now. So let's try to do this. If we take the derivative of y with respect to x, that means that the derivative of y with respect to x is equal to 8x to the third. We're taking this exponent and multiplying with the coefficient and subtracting 1 from the 4. And then we're using the chain rule, we get dx dx, which we know that cancels and we don't write that. We have not written this part so far, right? So now this is negative 5 times 2 is negative 10, reduce the 2 by 1, and then dx dx, and then 3, take the 1 times the 3, there's no more x, and that's dx dx, and those cancel, and we just get this. This is what we've been normally doing. Now why this is important is if we are going to take the derivative implicitly, we have to remember to use the chain rule. So these are explicit equations we just talked about. Now I'm going to talk about implicit equations, like this and like this and like this, where x and y are kind of all over the place. Okay, so let's try one. Let's take the derivative of y with respect to x. That's really important that you know which one you're taking the derivative of with respect to which other variable. So we're going to find the derivative. So we're going to take the derivative of x squared, which is 2x, and if we were using the chain rule, we would have a dx, but we don't really have to worry about that because we don't usually write that, and that reduces to 1 anyway. But this other one, the y, we have 2y, that's the derivative of the y squared, but then we have to take the chain rule. We have to take the derivative of y, which just is dy dx. I'll let that sink in for a second. And then on the other side, derivative of any constant is 0. This cancels, this reduces to 1. And what are we trying to find? Dy dx. We just want to solve this whole thing for this part right here. So I'm going to subtract the 2x from both sides of the equation, move that over here. Divide everything by 2y so we can get dy dx by itself. Play around with a little reducing and simplifying, and we get dy dx, the derivative of y with respect to x, is equal to negative x over y. And now we've found dy dx. Okay, just make sure that you clarify that the denominator can't be 0, and we're finished. It's not that bad, right? Let's do another one. Or actually, let me give you some examples. Right here, we're going to take the derivative with respect to x. And since these variables agree, we can just take 3x squared, and we can ignore the dx dx. Okay? Variables agree, use the simple power rule. Now, the variables don't agree, so now we're going to have to use the chain rule. We can go 3y squared, that's the derivative of this part, and then we have to take the derivative of y, which is dy dx. If you get confused, this is straight out of the book. In fact, I just copied this right out of your textbook, so you can go back and look at it. And they elaborated a little bit more, and it's nice to see it from some other person's perspective besides mine. Okay, how about this one? All right, so now we know that the derivative of a sum is the sum of the derivatives, so we can take the derivative of these two separately. So we can have derivative of x is just 1 times dx over dx, which we don't write, and then we have the derivative of this, which is just 3. The y goes away, and then we take the derivative of y, which is dy dx. Okay, use the chain rule, right? Take the derivative of the inside. This looks funny here if you don't think about it this way. That's why most people, especially at the beginning of teaching this, we always write it this way. If we write it this way, you just think, oh, just put a little apostrophe on the y, and that's not really what's going on, okay? How about this one? This is the product rule. Okay, so we're going to separate it into the first times the derivative of the second. So this is, we're just writing, we haven't done anything, we just said I'm going to take the derivative with respect to x of this, and then the second times this, I'm going to take the derivative of this with respect to x. Now we're going to actually take the derivative, that's x, taking the derivative of y squared is 2y, chain rule, dy dx, and then this is just 1, so that's how we do that. We simplify, and that's what we get. Okay, hope you understand that. See if you can work through this. This is going to be a little bit longer. It might take you half a page, so you want to give it a try. Really, really good practice. You know that I don't give you a lot of practice on the video, so there's only this example and one more. Okay. So if you're ready, here we go. We're going to take the derivative of y to the 4th. We're going to use the chain rule. So we're going to take 4y cubed dy dx plus, we're going to take the derivative of 3y, which is 3 dy dx, chain rule, minus 12x squared Ooh, where's my squared? Just pretend there's a squared there. It's a little typo. And then equals 5. And that's the derivative of that, with the dx. And next step is to, well, actually I don't like this step here. I typed it in, but we'll just skip it because I just wrote this as prime. And I don't really, at the beginning, I don't want you to write this prime stuff yet because you're going to forget where it came from. It comes from this, and that's kind of really important because we're solving for this. If it says solve for y prime, then go ahead and write this. But as a little shortcut, we write this normally. Okay, so moving the negative 2x squared to the other side. Sorry about that. Just remember there's a little squared here. And in fact, give me a second here. Actually, put a little squared here so you don't forget that it's squared. All right, okay. So, and then we factor out the dy dx, and then we divide both sides by this, our factor, okay? And then we get that. Just let me put a little squared here too. And right here. That's pretty good for doing it with a mouse. All right. And that's your final answer. Make sure you say that the denominator doesn't equal 0, and we're finished. Not really that bad. It's some algebra. This is kind of the meat of calculus. Okay. One more example. See if you can work this one all the way through. If you like, I would if it were me, because this is the end of the video. All right, you ready? Here we go. Okay, take the derivative of 2x, you get 2x dx dx plus 2y dy dx is equal to 0. Derivative of any constant is 0. Now subtract the 2x to the other side. Okay, there I go. I switched. You know what? I think there's one more example, a long one after this one, because this one I already did for you earlier with a 4 on this side. Okay, so hopefully you'll remember that it comes out like this, and it doesn't matter what this constant was on this side, the derivative is going to be this. If this makes sense to you, if you know what this graph of this is a circle, and the derivative is the slope, so the slope should be the same as the last problem with the 4 on this side. All right, here, and then make sure that the denominator is not equal to 0, and box your answer. We're moving on to the last example. All right. Don't let it scare you. This is just do each term at a time. There are 1, 2, 3, 4, 5 terms on this side, but one step at a time. There's a product rule going on in here and so on. Okay. Good practice with the product rule and your implicit differentiation. All right. So first, I'm going to look at it this way because I don't like to worry about the coefficient out in the front. So I take that out first. And then doing this first part right here, inside here, is product rule. So it's the first times the derivative of the second, dy dx, plus the second times the derivative of the first. Okay, you want to try this next product, pause it, and then come back. All right, how about this? This is the first times the derivative of the second plus the second times the derivative of the first. I always put this in parentheses or brackets or separate it because I have to distribute this negative sign. I don't want to forget that. And then the derivative of 3x should be 3x squared minus 5. Derivative of any constant is a 0. Okay, simplifying, I get 12xy squared dy dx plus 4y cubed minus 2x squared dy dx minus 2xy plus the rest of this. Now I want to move all the terms without the dy dx to the other side and factor out a dy dx on this side, which are these two terms. Everything else goes on the other side. Divide by this factor here to get dy dx by itself. And we get this, and the denominator can't equal 0, and we're finished. All right? Good job. You're welcome to look in this section with implicit differentiation in your textbook. And I'll put the page number right here when I compress this video. Okay? All right.